Okay, tangents and normals up next. The curve C has this equation, y equals x squared minus 8x plus 14, so it's a U shape. The point P has coordinates 6, 2, I'm just going to pick a random point, let's go there, and that's going to be P, and lies on a curve. Find the equation of the normal to C at the point P. So, as a reminder, we have tangent, which looks like this, and a normal, which is perpendicular to that point. And I want the equation of the normal. Now, to be able to work out the equation of a normal is a straight line. Here's your straight line formula. We need, first of all, a coordinate to be able to substitute into that. Now, from this question here, the coordinate, I'm going to use the point P, because P here is on the curve, is on the tangent, and is on the normal. So I can use it for any of those equations. So there's 6, 2. The gradient of the normal, though, is the thing that I don't have. So that's my first task. You can work out the gradient of a straight line in a few different ways. Obviously, if you're given two coordinates, you can use y2 minus y1 over x2 minus x1, but you don't have two coordinates. But a tangent, you find the gradient for a tangent by differentiating the curve. So if I find dy by dx, it is 2x minus 8. This is the general expression for the gradient at any point on this curve, but I want it specifically at this point P, and specifically when x is equal to 6. So 2 times 6 minus 8 is 4. So the gradient, that is the gradient of the tangent, but I don't want that. I want the gradient of the normal, negative reciprocal, because they are perpendicular. So the gradient of the normal is now not unknown. It is minus a quarter. So we stick all that in, and it is y minus 2 equals minus a quarter x minus 6. So y minus 2 equals minus 1 over 4x plus 6 over 4, which I'll leave it like that for now, times 2 by 4. 4y minus 8 equals minus x plus 6, x plus 4y minus 14 equals 0, if you want to rearrange it like that. Part B. The point Q lies on C, the curve, somewhere, and is such that the tangent to C at Q, I'm just going to pick a random point according to the question that will be relevant. Let's go for like there, for example, I don't know. So the tangent to C has this equation. So there's a separate tangent there, and that tangent has the equation y equals 2x plus c at this point Q. Find the coordinates of Q and the value of C. So what's happening here? We have a tangent to this point, and the tangent at this point, the gradient of that tangent is 2, because it's y equals mx plus c. That's a really important fact. So that means that if I want to put the expression for the gradient, don't forget that that was 2x minus 8 earlier, equal to that, I'm saying that the gradient equals 2 at this specific point. Then I can rearrange this, give me 2x equals 10 and x equals 5. That means that the x coordinate at point Q is 5. So you're using the fact that you know the gradient of the tangent to put it equal to the expression of the gradient to rearrange to give you your x coordinate at that point. We need a y coordinate though, so you're going to sub x equals 5 into, now you have an option, this coordinate is both on the curve and on this tangent of y equals 2x plus c. I say you have an option, I wouldn't use the y equals 2x plus c because you don't know what c is. So I'm going to put it into y equals x squared minus 8x plus 14, which is 5 squared minus 8 times 5 plus 14. 25, take away 4, minus 15, minus 1 at that point. So obviously my diagram is not drawn to scale, as it turns out. It also wants me to find a value of c. So here's my equation, y equals 2x plus c. I now know x, I now know y, sub them in, and it's going to give you c. So y, we just worked out, was minus 1, equals 2 times x, which was 5, plus c. You rearrange that to give you minus 11 for c.